This is going to be functions and relations. So our success criteria for today is to understand the aspects of a function, so what makes a function. And we're going to be able to identify domain and range. And we're going to evaluate functions using function notation. So you had some vocabulary words when you walked in. However, here are some explanations of some of them. So a domain is the x value. It's the input. It's the independent variable. So your domain are going to be your x values. Okay. Your range is going to be your y values, your output, the dependent variable. Relationship is a set of x, y values. A lot of times they're written as ordered pairs, like so x, y. Functions are a set where every x value is different. Okay, that's the key thing here, that your x values have to be different. If you have a repeating x value, then it's not a function. Okay? But my y's can repeat. You could have a different x and all the same y's and it'd still be a function. Okay? So, you can view graphs or functions as ordered pairs. Okay, so that I went over what an ordered pair was. So we put it in parentheses like so. Or a table of values, which we'll see on the next slide. A graph or a map. This is a map. Okay, in order for a map to be a function, your lines have to go from only one x. This would not be a function if I had a line going, two lines coming from an x value. Okay, that would make this not a function. Okay? So those are some ways that we can look at a function and determine if it is a function. Or look at a ordered pairs, a table, a graph, mapping, and we can determine if it's a function. So, is it a function? To determine if a table, mapping, or a set of ordered pairs represents a function, check the x value. If every x is different, it represents a function. So, is this a function? If so, state the domain and range. So we're going to look at our x values. Is every single x value different here? No. So this is not going to be a function. So this is no. And it's because the x value 0 and 2 repeat. Okay? So you probably want to write that down here. No, the x value 0 and 2 repeat. So if our x values repeat, then it's not a function. Erase. Yep. Okay, is this a function? If so, state the domain and range. Okay, do my x values repeat? Are there more than one line going from them? No, there's only one line going from them. So is this a function? Yes. So yes, this is a function. So I'm going to now need to identify my domain and my range. My domain are my x values. Those are the values that are in my left side of my map. So my domain would be 1, 2, and 4. What would my range be then? Yes. 0, 2, and 3. Awesome. So vertical line tests. tells if a graph represents a function. A relation is a function if and only if no vertical line intersects at the graph of the function at more than one point. So I know that these are kind of hard to see, so I'm going to zoom up on them. So if we're looking at these graphs on the left here, I can probably zoom in a little bit more. You're going to, when we're doing a vertical line test, you can take like your pencil or a ruler or anything that's a vertical, you can make into a vertical line. And we're going to check to see if it crosses our graph in more than one spot. So I'm going to take my pencil or whatever I'm using, and I'm just going to go across my graph at a vertical line. If it doesn't cross in more than one spot, it's a function. So here, it only crosses in one spot, so that's a function. Here, it only crosses in one spot no matter where I put it, so it's a function. Same thing here. Do we see how it only crosses in one spot? So it would make it a function. Same thing here with this next one. It only crosses in one spot, so it is a function. If we look at the ones in the next little box, you can see that my vertical line crosses in two spots. So this would make this not a function. It means that the x values repeat. Same thing here. My vertical line crosses in two spots, so it's not a function. Same thing with this one. Crosses in two spots, not a function. Here, this crosses in three spots, so it's not a function. Okay? So on this slide, we're going to label those graphs on the left side as a function, and the graphs on the right side as not a function. So these ones are functions. These ones are not functions. Because of the vertical line test. Okay, so let's look at some examples. So we're going to tell whether or not these graphs are functions. So our first graph here, number 1, is this a function? Yes or no? Yes. You guys look at the first slide on the back page. You can take your pencil and see if you can do a vertical line. Okay. Does it cross in any spot? See, I can go like this. Does it cross at all in more than one spot? No. So yes, this is a function. How about number 2 here? No. It obviously crosses in more than one spot. So this is no. And how about 3? No. All vertical lines are not functions. Okay? A vertical line cannot be a function. So no. So that's how you identify if something is a function. You check to see if its x values repeat, if you have a chart, ordered pairs, or a mapping. And then for graphs, you do the vertical line check. Okay? And our last thing that we're going to be going over is function notation. Naming a function using a variable, usually f of x, or f parentheses x. This is pronounced f of x. It's the same thing as y. I'm sure that you guys have seen the equation y equals mx plus b, right? Instead of using y now, because we're identifying that this is a function, we're going to be using f of x instead of y. Okay? It's to identify that something is a function. Sometimes they use like g of x or h of x, but it all means that it's a function. They're naming it now. Because we're going to be given multiple lines that we're going to be putting on a graph, and we have to name them different things. We can't just name them all y equals mx plus b because there's going to be multiple of them. So we'll name one like f of x and one, y equals mx, or f of x mx plus b, and then g of x, and then h of x, or whatever else, because they now have their own identities. Okay? So how we solve these, we substitute the given value into the function, okay, and then we evaluate. So for example here, I have the equation f of x equals negative 2 plus 3x, okay. When I'm looking for my f values, I'm going to substitute the f value that's in the parentheses in for every single x, okay. So this is going to become f of 1 equals negative 2 plus 3 times 1. We always, anytime that we substitute a value in, you always put it in parentheses. Okay? So now I just solved my equation. Okay? So 3 times 1 is 3. Negative 2 plus 3 is 1. So f of 1 equals 1. Yes. I'm sorry?
Like why you use the
Yes, because it told me f of x is 1. Sorry. Did you see how here we told me f of 1? So we're substituting 1 in. Right, so if I'm substituting 1 in for my f equation, what am I substituting in for my g equation? What's the value there? What? Negative 2. Okay? So for my g equation, because they tell me g is negative 2, so I'm going to substitute negative 2 for every single x. But remember, you always have to put it in parentheses. Okay, so now I'm finding negative 2 squared, which is 4, but I have an opposite on the outside there. So that would become negative 4 plus negative 2. What is negative 4 plus negative 2? Negative 6. So g of negative 2 equals negative 6. So that means that my y value would be negative 6 when my x value is negative 2. Okay? Because remember that the f of x and g of x are just replacing y. You know, that's going to be probably a little bit confusing part, but now we're just going to be practicing with homework, okay?